Good afternoon, everyone. So today we are going to discuss about zero liquid discharge system. Myself, Kumar, and let's proceed. So, what is zero liquid discharge system? Would be the first question you would have. Zero liquid discharge system can be defined as a waste water management system which treat and recycles nearly all wastewater generated, right? All the wastewater which is generated in industries or any other sector, it will treat and recycle it for the further use, right? Now, the ZLD sector was apparently born in 1970s in USA with the tight federal regulations on salt discharge to surface water introduced, especially due to the salinity problems in the Colorado River. Regulations were mainly concerned with power plant discharges from cooling tower blowdowns, scrubbers in the wake of previously introduced regulation on flue gas discharges basically. Now, the Clean Water Act 1974, which was revised again in 1977 and then in 1982, the first ZLDS, well, it is ZLD system, that is zero liquid discharge system, was installed, where 500 to 2000 GPM units based on evaporation and crystallization. The zero liquid discharge, or like what is the use in the today's scenario, like in the today's generation, as you know that the scarcity of water is growing day by day. As you can see in Bangalore nowadays, the water availability is very less. So nowadays the scarcity of water is concerning the reality, and the environmental aspects has become a majority, has become a major priority, right? That leads the industries towards the method that can reduce the generation of wastewater and can reuse it. So just underline this point. It so what does zero liquid discharge do? Basically, it reduce the generation of wastewater and or can reuse it, right? So there are some advantages of zero liquid discharge, and every advantages have limitations also. So the advantages of zero liquid discharge is that it help to achieve environmental compliance, reduce carbon footprint, create positive public precipitation, and recover high purity water for reuse. So these are the advantages. I repeat, it help to achieve the environmental compliance. Okay, so let me underline. So you can see here, it helps to achieve the environmental compliance, it reduces the carbon footprint, and it create a positive public precipitation and recover high purity for reuse, right? Next, what is the definition, like definition of zero liquid discharge as per the CPCP? So what is it? Let's see. So the zero liquid discharge refers to installation of facilities and systems. Okay, so basically, so what is zero liquid system discharge refer? Like what does it refer to? It refers to installation of facilities and systems which will enable industrial effluent for absolute recycling of permeate and converting the solute, that is the dissolved organic and inorganic compounds slash salts into residue in the solid form by adopting method of concentration and thermal evaporation. Now, where can we recognize this ZLD method, right? ZLD will be recognized and certified based on two broad parameters, that is water consumption versus water reused or recycled or recycled. Okay, that is water consumption versus wastewater reuse or recycled. It is preeminent. You can say preeminent, and corresponding solids recovered, and the corresponding solids that are recovered, that is we have a formula called percent total dissolved or suspended solids in influent. This is what the solids that are recovered, the corresponding solids which are recovered. Next we'll see, next is the we'll see next. Okay, 1 minute. Yeah, so next, zero liquid discharge. So these are some definitions, and there's something about the zero liquid discharge which you need to know. That's how the whole system of zero liquid discharge works. So basically, a zero liquid discharge is a series of processes like membrane filtration, reverse osmosis, evaporation, and crystallization that extract pure water from industrial influence. So it just extracts the pure water from the industrial influence, leaving behind the sludge, dissolved solids, and suspended particles and salt crystals, as you can see, and salt crystals. The prerequisite for ZLD needs physical and chemical treatment followed by biological system to remove the organic load. Now the treated effluents can be subjected for concentration and evaporation. Okay, it can be subjected for concentration and evaporation. The concentration method quite often involves the adoption of reverse osmosis and nanofiltration methods. So basically, if we're going with the concentration method, it basically it adopts the reverse osmosis method or the nanofiltration method. With further, we'll be using the abbreviation as RO, and for nano we'll be using the abbreviation as NF. The evaporation method, the second method, that's the evaporation method, involves the incineration, drying, evaporation of effluent in multi-effect evaporators. What is multi-effect evaporators? What is this method? Also we'll see in different industries in the upcoming PPT slides, right? That is MEE is the abbreviation for this thing, right? Just remember the abbreviations MEE, NF and RO, what it is. Now we'll see definition as per the CPC. So what is the definition? We have seen this, right? So let's just proceed. Liquid discharge. Now what is the need for ZLD? So why do we need ZLD? Basically, the most polluting industries such as pharma, pulp and paper, tanneries, textiles and dyeing chemicals, power plants, etc., generate wastewater with high salinity or TDS, right? The the conventional or psychobiological, like we can say psychobiological psychochemical biological treatment does not remove the salinity from the treated effluent, right? The TDS content is well about saturated, uh, of 2100 mg per liter, and this discharge of saline, but there is a discharge of saline, but treated wastewater pollutes ground and the surface water. That's these are some This is why we need the ZLD system. What are the other things that we need for ZLD system? Like in India, basically several states in India, including Tamil Nadu, are water stressed. You know how there is water scarcity during the summer season in Chennai or in Tamil Nadu, we can say. So competing the demands for water from agriculture and domestic use has limited the industry's growth. Now, for this, the Tamil Nadu government has taken a lead on ZLD, that is zero liquid discharge, due to the absence of fully flowing perennial rivers. Other states such as even Gujarat and Karnataka also considering the ZLD. You know the recent case of Karnataka, like there is more water scarcity over there. What are the main motivators for the need for ZLD? That is water scarcity, water economics, and regulatory pressure, right? Next, we will be seeing the legislations related to the ZLD in India. So, the first legislation which is related to ZLD in India is that the Supreme Court of India, right? The Supreme Court of India directed that the polluting pharmaceutical industries near Hyderabad to pay farmers rupees 400 per acre annually between 1992 to 2002 due to the loss of soil fertility that happened over there. Next, the Tamil Nadu High Court ordered, the Tamil Nadu High Court order mandated ZLD for dyeing, bleaching units, tanneries, and distilleries on the year 2006. The Andhra Pradesh High Court ordered mandated the ZLD for 12 large pharmaceutical units around Hyderabad, discharging 25,000 KLD in the year of 2008. Even the Tamil Nadu government and the central government scheme for subsidy of rupees 320 crore interest free loan to set up the ZLDS system, that is the ZLDS system, that is the zero liquid discharge system in the state following the court order of 2006 in the year 2010, right? And then even the Punjab Pollution Control Board mandated the ZLD in 8 large electroplating industries in Ludhiana in 2010. 2010. And now the Punjab Pollution Control Board assisted 500 plus small electroplating units in Ludhiana to set up the CETP with ZLD, that is ZLD, in 2010. The Rajasthan government declared a capital subsidy of on ZLD based on effluent treatment plant equivalent to 20% of amount paid to the suppliers for the plant, excluding the civil work, subject to a maximum of rupees 1 crore in the year of 2010. These are some legislations related to ZLD in India basically. And so what are the potential markets for ZLD? Like the treatment and recycling of industrial effluents. What are the potential market we're going to see? So the potential market for ZLD are power. First is power, petroleum and petrochemicals, synthetic fuels, primary metal processing, oil refining, microelectronics, chemical, steam assisted gravity drainage, that is SAGD, heavy oil recovery, cogeneration, pulp and paper, coal mining, fertilizers, solid waste, that is secondary sewage effluent, and battery manufacturing, PVC manufacturing, coal liquefaction, ethanol production. Okay, so these are some treatment and recycle of potential markets for ZLD, as you can see. And more potential markets are tertiary treatment of municipal waste effluents and inland desalination, or we can say desalination something, right? Okay, now next we'll see these are the potential market. What are the current initiatives for using ZLD? Presently, the current initiative for using ZLD are environmental regulations on discharge of specific solutes like salt, toxic element, nitrate, nitrate, etc. Water scarcity or water stress growing worldwide, along with a still negligible rate of wastewater recycling. Economics, that is recycled water becomes more affordable as that water supply from conventional sources becomes more expensive. Then growing social responsibilities and educations towards awareness of environmental issues. While ZLD cost is high, the zero liquid discharge system cost is high in most cases, the it might be more economic solution than when the waste needs to be transported in large volumes over long distances, right? Now next we'll see more initiatives. These are current initiatives, and next we are going to see the limitations. So what are the limitations? It's not like everything is perfect, right? There is limitations in everything. So what are the limitations of zero liquid discharge? First of all, it's very high cost. The both capital expense and operating expense, it's very high. Second, the custom design on case to case basis. Okay, the custom design on case to case basis. And third, difficulty to deal with complex streams, like example petrochemical industry. So it's very difficult to deal with it, right? Petrochemical industries. Next, what are the challenges faced in ZLD? So basically, while the benefits of ZLD is significant, right? It's so the adaptation of the technology has two key environmental consideration, that is the energy consumption of the for the evaporation process, disposal of the solid waste. The energy cost for evaporation accounts for over 90 percentage of the operational expenses of ZLD. There is also the issue of dealing with the highly toxic rejects of a ZLD plant. Presently in Tamil Nadu, there are destinated landfills zone away from the industrial centers for disposal of sludge. This increase the cost for the manufacturers because they have to store the sludge before transporting it to far off locations, but this also does not resolve the issue of water disposal. And then what is the concept of ZLD and the treatment options and the sector wise we are going to see. So we are going to see here a total 9 sectors. From the first sector is distillery. The distillery, the first thing is biomutation, followed by RO, that is reverse osmosis, ME, as I told, followed by increation or slope fired. Biomutation followed by RO or ME, followed by drying, that is spray or rotatory. Concentration through ME, followed by core processing instruments or thermal plants, power plants. Biomutation and RO, followed by ME, followed by biocomposition, as per the new protocol. And here the remarks is that ZLD is achievable. In the tannery industry, primary treatment plus secondary treatment plus pre-treatment for RO, plus reverse osmosis plus ME, that is recover of permeate, crystallized salt and reuse of recovered condensate. Here also ZLD is achievable. Now, pulp and paper. In the pulp and paper industry, primary treatment plus degasification plus RO plus two stage of plus NF and UF, plus evaporator and concentrate slash crystallizer. Here, a black liquor totally to be ZLD in any plant. Other plants ZLD as per the chatter concept. And next we see sugar. In sugar industry, restricting the effluent generation to 1000 sorry not 1000 liters per ton. Can crushed water consumption to be restricted to 100 liters per ton initially, and further to 50 liters per ton. Can crushed condensate, the polishing unit mandatory recycle of excess condensate to process or ancillary to the units. Water management and audit to reduce. These are some irrigation protocols for disposal into land average. So these are some methods, as you can see. What we have mentioned is the treatment options, and here also water conservation and irrigation protocol are as alternate to ZLD. Next we will see pharmacy in the pharmaceutical. So what is the methods? Low TDS effluent treatment system and high TDS effluent treatment system. What is low TDS effluent treatment system? Primary treatment plus secondary treatment plus tertiary chemical treatment to reduce the TDS, that is pressure sand filter, activated carbon filter and filter pressed for dewatering of sludge. Now the RO system permeate is utilized as cooling tower makeup water plus multi effect of evaporator incrementation. Here also ZLD is achievable. In a high TDS effluent treatment system, primary treatment plus striper to remove the VOC plus three stage multi effect evaporator, forced circulation, agitator, thin film dryer, ATFD, and ME condensate is being taken along with the low TDS effluent for further treatment plus ME or slash inky. Okay. Next we'll see is for textile industry. So for textile industry, you can see the ozone plus biooxidation plus sand filtration plus activated carbon absorption plus microfiltration plus reverse osmosis three stage plus multiple effect evaporator. Here then after that ZLD is achievable. Here also you can see chemical precipitation, biooxidation plus chemical precipitation plus sand filtration plus activated carbon observation plus micron filtration plus reverse osmosis three stages plus multiple effect of evaporator. And here in third method is chemical precipitation plus biooxidation plus sand filtration plus dual medial filtration plus micron filtration plus reverse osmosis three stages plus multiple effect of evaporators. Here also ZLT is achievable. Now we'll go to the industry of refineries. In refineries, API, primary treatment, secondary treatment, tertiary treatment. The tertiary treatment is mainly reverse osmosis and permeate is utilized and rejects are discharged into cooling tower. Here water conservation, reuse and partial ZLT is done. Next, fertilizers. In fertilizers, chemical treatment plus reverse osmosis rejects as filler materials permeate in the process. Here also water conservation, reuse and partial ZLT is done. Dye and dye intermediates, chemical treatment plus ME. Here ZLT is achievable. So this is about the ZLT, that is zero liquid. You can say it as zero liquid or zero liquid discharge system, right? Now we will see. I'll just show you a poster. Okay, so let's see this poster. As you can see in this poster, right? What you can see in this poster is the ZLD process. This is the ZLD process we are seeing here. Okay, the zero liquid discharge. The zero liquid discharge system can be defined as a water management system which treats and recycle nearly all generated waste. So this is what are the phases in the zero liquid discharge, you can see over here. Phase 1 treatment, phase 2 membrane filtration, phase 3 evaporation, phase 4 crystallization, and phase 5 is solids recovery. So this is the phases we have. That's the 5 phases of zero liquid discharge, you can see over here. And next, the ZLD, if it combines with RO membrane, here you can see what is happening. Here you are giving a wastewater, okay, here you are giving a wastewater, then the filtration or pre-treatment is happening in concentrates, the crystallize, and then the evaporation collect the recycle waste. This evaporation or crystallize and concentrates and collect the recycle waste. Here even you can do this is A method, and this is the B method, as you can see over here. Thank you. I hope so. This video was informative about the zero liquid discharge. Myself again, Shashwat Kumar Das, and I hope so you enjoyed. Thank you.